So the second talk is going to be about my hobby project, another open source project which is called Spock. So again, a few questions in terms of, let's say, unit, integration testing, lower level testing. Who of you is using JUnit for that? JUnit, anyone? Okay, a lot of people. Anyone using test-ng? Quite a few hands. Something else, maybe RSpec or something from the Ruby world. Anything? Anyone using Spock? Yes. Okay. With that, let's get started. So what I'll talk about, I've been told I have around 30 minutes because the pizza means you get tired and it gets dark. That together means I have around 30 minutes for this talk. I'll talk a little bit about what is Spock, since most of you probably haven't heard about it. And then there are three major parts of that talk, three different kinds of testing which do not just apply to Spock but are general ways to do testing: state-based testing, data-driven testing, and interaction-based testing. And if we have more time, then we'll talk about some more cool stuff and Spock extensions and so on. So what is Spock? Spock is a developer testing framework, so it's really targeted at developers. It's specifically meant for Groovy and Java applications, so it's perfect for testing Groovy code, but also for testing pure Java code. Itself, it's based on Groovy, which means when you write Spock tests, you write them in Groovy. So your tests will always be in Groovy, but your production code can be pure Java. It's fully compatible with JUnit. That's very important for the tooling integration. It means any tool that understands JUnit and understands Groovy understands Spock, which means typically nowadays all your IDEs, your build servers, your build tools, for them is just another JUnit test written in Groovy. But we really try to go beyond JUnit. We think there are too many JUnit clones already. At this point, I sometimes say JUnit clones like test-ng, and I hope people will laugh, but most of them don't, so I don't say it here. But we really try to bring something new to the table and not just do a small change to JUnit, some JUnit in Groovy. We really try to use all the features that Groovy provides to make you more productive and make testing more fun. So what can you expect by using Spock? You can reduce the lines of code. Part of that is Groovy. Groovy is much more concise and expressive than Java, but it's also that Spock that allows you to be more expressive, make your tests more readable. So our goal is that your tests, whether they are unit tests or integration tests or acceptance tests, and you can use Spock for all of them, should read like specifications. So they should read like a specification of your production code. And not as a thing that you cobble together 5 minutes before the release just to see if it really works. It's very extensible, so you can extend Spock yourself, and many of Spock's features that come out of the box are actually written as extensions. And we try to bring back the fun to testing, a little bit at least. So how do you get started with Spock? There's the homepage, spockframework.org. The source code is on GitHub. There's a new documentation effort, docs.spockframework.org, so that will become the new reference documentation. It already has quite some content. There's also the Spock web console, so if you just want to give it a try, and I won't try the Wi-Fi now, but it's just, you can just try Spock in your browser and just run it without having to install anything. There are examples there that you can try. There's an example project also on GitHub that comes with a fully working Ant build, Maven build, Gradle build. You can generate IDE projects, so immediately try Spock in IntelliJ IDE or Eclipse. So with that, hopefully it's easy to get started. And also all the slides and code for this presentation are also available on GitHub. If you just remember GitHub spockframework.org, then you're fine. Who's using Spock in the open source world? A few projects. Spock itself, we are using Spock to test Spock, of course. Grails, the Groovy web framework, they are big fans of Spock. Apache Tapestry is another project. They by now write all their tests with Spock. I've seen some Spock tests sprinkled over Spring code bases here and there a little bit. Gradle, of course. Nowadays I only accept positions at companies that allow me to use Spock at work. And a few others. Asgard is another one from Netflix. Netflix are also big Spock fans. GPass I have on the list as well. In terms of companies, basically you find here most of the companies I worked for. That's how I usually do it. I infect them with Spock and then I move on as quickly as I can. But there are also some others like Netflix or BSkyB. That's a big British telecom pay TV channel, and they have a big Rails app. That's actually their public website, and they also write their tests with Spock. A lot of them are actually Grails shops, so in the Grails community, Spock is very popular, so lots of those companies are somehow involved in Grails and those also in Spock. Okay, with that, let's get to the first part, which is the state-based testing. And the demo will come up quickly. Just a word, what is state-based testing? It's the classical form of unit testing, as you've all done it many times. You can split it up into 3 phases. They are sometimes called arrange, act, and assert. So in the arrange phase, you set up your code. For example, you create the object under test, you instantiate it. In the act phase, you exercise the code under test. And in the assert phase, you have your assertions, for example, with the JUnit assert class that check the state of the object under test. That's why it's called state-based testing. And another way to put this is given, when, then. So the given phase, that's where you set up the stuff. The when, that's where you exercise the code. And the then is where you make your assertions. So now I need some code. So let me have a look. Here we go. First of all, we need some code to test. And I've tried hard to come up with the most boring possible example. We need something to test. And I'm sorry, the font is really small. I have to change that. Shouldn't have had so much pizza. Now it should be better. Okay, so this is the class we are going to test. It's a boring count class. It's written in Java to show you that Spock works just fine for testing plain Java. So this is a count which has a balance. You can ask it for the current balance, and you can withdraw some money. And so the only really interesting method is the withdraw method over here. And there's one interesting thing here. We check that the amount withdrawn is non-negative, right? Because it would really be cool if I could withdraw minus $10 million from my account, because then I would be left with 10 million. So that's why we have this check in here. And other than that, we just subtract the amount from our current balance. That gives us a new balance. And the balance is a big decimal, which means you have to write a bit of boilerplate in Java to deal with big decimals. Okay, so how would a state-based test for this class look like? First of all, let's look at a JUnit test. So that would be a JUnit test for that withdraws some money. So we set up an account. That's the arrange phase. We instantiate the account object. Then we withdraw some money too, and then the assert phase, the then part here, we check that 3 is left in the account. And back in the time when I was a heavy JUnit user, I would often annotate my test this way. And I found this really helpful. These are the 3 phases. Given an account with a balance of 5, when we withdraw 2, then we expect 3 to be left. So this is a really good way to think about this. Now, how would the same test look like in Spock? So we like to call our test specifications. That's why I called it account spec here. And this is not the most idiomatic way, but just to show you how similar it is to the JUnit test. So this is now written in Spock and Groovy instead of JUnit and Java. So for those of you who don't know Groovy, it's a language that's syntactically very similar to Java. Actually, most valid Java code is also valid Groovy code, so you just have to rename it and it still works. And that's kind of what I did here. So I didn't use any cool Groovy features. I just wrote it in Java style. So Spock class, test class, always extends from the specification class. Then here we have the method, and then we have the 3 phases again. The first thing you see that is different is that these 3 phases, the given, when, then, are now no longer comments. They are first-class concepts in Spock. So Spock knows what this this setup phase and the arrange phase and the act phase, what they are. It understands them. So what do we see here? In the given phase, you write it like this, given in a column. A column, technically that's a label. You could even write this syntax in Java. So it knows the code that follows this given is setup code. Here you set up your account. Then it knows that what follows the when, this is where you exercise the code under test. And then here is your assertion. And here's the first difference, that we don't use any assertion API here. You see? It's just a plain Boolean expression. You simply say then the balance equals should be equal to 3. Because in Groovy the equals operator actually calls the equals method underneath. So let's try to run this guy. So you see, to the IDE it's just a JUnit test, so you get all the usual integration. Okay, it's passing. Now the interesting question is, what happens if it fails? Because why do all those testing frameworks have an assertion API? It's of course to give you a good error message in case it fails. Otherwise there's no point in an assertion API, because believe it or not, Groovy already has Boolean expressions. Right? You don't need an API to write Boolean expressions, except for the error messages. So the question is, since in Spock it's just a Boolean expression, what does the error message look like? And this is the kind of error message you get for free by writing Boolean expressions. So you get here, this is what you wrote, and here you see the values of all the sub-expressions. So you say, you see the actual balance was 3, you expected it to be 4, you compared it for equal, so that's false. So that's the kind of output, and if you happen to know Groovy, that's similar, that's an improved version of the Groovy power asserts that you see here. So in plain Groovy you would get a similar output actually, to some degree. Okay, so you can just use Boolean expression, don't have to have an API, and with Groovy you can write really powerful Boolean expressions, and we'll have some examples for that. Now let's look at a more idiomatic way. So this would be an idiomatic way to write the same test in Spock. So again, it's this class, the same specification, but now the method name is a string. You can make a method name a string and can just write out your requirement as a sentence, right? Because it should read like a specification. And once you get used to this tiny little feature, you don't want to give up on it anymore, I can promise you. So you just write, for example, withdraw some amount. Then you see in Groovy I can leave off lots of boilerplate code, lots of noise, I can leave out the semicolons. This is a big decimal, but I can just add it with plus and so on. In Groovy a decimal number is by default a big decimal. So then I say, given an account with a balance of 5, when I withdraw 2, then I expect 3 to remain. And I think that's quite a bit more readable than the original. I hope it's quite a bit more readable than the original JUnit code, and yet this has pretty much the same functionality. We can do a bit more. We can annotate it a bit more, so we can give some comments to all those blocks. So this, I wouldn't do this for a unit test, but if I write, let's say, an acceptance test, then I might write something like that. So you can give it some nice annotations. And actually, the Groovy runtime is aware of this. And right now, we are working on a new kind of high-level HTML report. So far, you just get the usual JUnit reports with Spock, but we're working on a new report that will show everything you annotate here, because the Spock runtime is aware of this stuff. So it's not just a code comment, but it will show up in some reports eventually. Other than that, this guy is unchanged. I have another one. This now gets a little bit more interesting. We want to try this withdraw negative amount. That's a bit more interesting. So again, we set up a new account, we withdraw -1, and we now expect that this, if you remember the code that checked for that occasion, and it would throw a negative amount withdrawn exception. So how do you express in Spock that you expect an exception to be thrown? And actually the easiest way is to say thrown. That's a method that comes from that base class, and then you say the negative amount withdrawn exception. So that's how you say in Spock, I expect this code, everything that follows after the when, to throw an exception. And again, the intention is that it's quite readable. When you withdraw -1, then this exception is thrown. You don't have to write any try catch or anything like that. Sometimes you want to go on and add further assertions, and then you can write it like this. The syntax is changed a little bit, and what this does is again expects that this exception is thrown, and if it's thrown, it saves it off in this variable, so you can now go on and check the state of that exception. So for example, in our example, the exception saved the amount that was tried to be withdrawn, that guy here, and so we can now check whether the amount saved on the exception is really that number up there. So it's very easy to add further assertions after checking that that an exception occurred. What else do we have here? A tiny little feature. You can express your assertion in that way. We expect the new balance to be the same as the old balance minus 2. So that's a more abstract way to put it. And then again, that old Spock knows that this is the code that's exercised. An old value of some expression is the value that expression had before it got to the WAN block, before the code under test was exercised. So instead of hard coding the value, we say after withdrawing 2, our balance should also be reduced by 2. So that's some of the base language that you get with Spock. Otherwise, it's very similar to JUnit. You have a test class that's structured into test methods. You can run the whole class or a single method or a subset of methods, similar to what you get from JUnit. So I could run the whole class here. It's all the same. And you see also down there, you get your nice sentences that you named your methods with, and you also get them in the JUnit reports. And that already makes it a little bit more readable. I have one more here to show you a few more advanced assertions. So for example, we want to test the maximum method of the math class. With when it would look like this. When you take the maximum of the two numbers, then you expect the maximum to be 9. And that's a little bit redundant, right? If you want just to test the return value of a method, it would be nice if you wouldn't have to go via this temporary variable. And that's why we have another block, which is called the expect block, which is a combination of when and then. So it both exercises the code under test and does an assertion. So you can say expect with some Boolean expression, and in this case this reads much nicer than the thing above. And again, it's a Boolean expression, and if it fails, you will get the usual output, which shows you all the values of all the sub-expressions. You can use any Groovy. So, for example, here the any method that checks whether for this get German car brands returns a list of strings. It's implemented somewhere down here. Here, that's our method under test. Returns 3 car brands, and we want to check whether any of them has a length. The string has a length of at least 3. And so there is any method in Groovy, you can pass it some predicate, and that's how you can easily form powerful Boolean expressions, more powerful than with plain Java, and you still don't need an assertion API. For those of you who are familiar with Hamgrest, that's another assertion library for JUnit. You can also use it with Spock. Now it gets a little bit more interesting. I'm comparing 2 bodies of text, right? 2 large bodies of text. So the method under test is this method here. This one, and this is my expectation. And now let's introduce some problems here, and let's see what output you get. It's still just a Boolean expression, right? You didn't tell Spock that you want to compare 2 bodies of text or anything like that. It's just a Boolean expression. Nevertheless, Spock understands that you compare 2 bodies of text for equals and gives you some more output. So for example, it tells you there are 3 differences here, 99% similarity. Then it also tells you here where they are different. Here, for example, you see here the O is missing down there, but that's still a little bit cumbersome. If you happen to use an IDE like IntelliJ or Eclipse, there's a much better way to find the differences. You click this one, and now you get a diff dialog. And in the diff dialog, you see exactly where they differ, the 2 versions. And we have that both for IntelliJ and for Eclipse. Actually, that works not only for strings, but it works whenever you compare 2 objects with equals, you get such a diff dialog. So for example, let me show you one more. We are comparing 2 photos here, a person class with a name, an age, and an address. And let's make something here. And we're comparing them with equals, right? We expect them to be equal. And the equality on them is just implemented in terms of those properties. So now they're no longer equal. And again, we get and so since they don't implement the toString, that output is not very helpful, right? If they would implement a good toString, you would see it here, but as such, this is not very useful. But the diff dialog to the rescue, and you see here, they differ in their address and their name. I hope you can see it from behind. The colors might be a little bit difficult to spot. They're certainly difficult to spot for me. But you would see that they differ in the address and the name, but the age is the same. And so whatever you compare, if you compare some sets or lists or maps, Spock always tries to give you such a diff dialog to show you how those objects differ. Okay, so much for state-based testing. And a short introduction into Spock. So what we saw is that in Spock a test method is separated into blocks, like expect and when and then. Actually there are a couple of more of them which we haven't seen. There are also fixture methods, like you know from JUnit, this add before and add after. There are similar methods in Spock. We've seen how to check for exceptions and this tiny little old thing. And the one thing we haven't seen here is shared fields. So if you want to share some states between test methods, that is something that you wouldn't want to do by default, because you should try that they are independent of each other. But if you write higher level tests, like integration tests, sometimes they want to share some states. And in JUnit you would make your field static. That's how you would share it between several test methods. And with Spock there's also a shared annotation, which is a little bit a smarter version of sharing state between different test methods. Okay, with that, we'll get to data-driven testing. What is data-driven testing? It's just an extension of state-based testing. You could still say it's a form of state-based testing, but you test the same behavior multiple times and you just vary the data. So you vary the inputs and probably then also the outputs. So you run the same test method multiple times, but just vary the data. And that's a very powerful way of testing. And that's why I have an example here. Let me see, data-driven. So we're testing the same account class. But now we we start with different initial balances, we withdraw different amounts, and we expect different ones to be remaining. So how this works, the first part is exactly the same as the method before. The new block is the where block. And the where block is very versatile. Basically how it works, we introduce some variables here. Instead of using concrete values, before we were using 5,0 here, now we just use a new variable here that we haven't declared, balance. And here we also use a new variable, and what we expect to remain in the account, we also use a new variable. And then the only difference is the new block, the where block. This is where we assign values to the variables. And you read it like a table. So the first line is the header. These are the three variables that correspond to the variables up there. And then for each line, this test method will be run once. So in this case, it will be run 3 times. And the first time, we call it an iteration. The first iteration, the initial balance will be 5, we withdraw 2, and we expect 3 to be remaining. Second run, balance is 4, initial balance, we withdraw nothing, and we expect 4 to be remaining. This is a very convenient form if you want to inline the test data into the test method, but actually the where block is more versatile, and you could also fetch, for example, the test data from an external source or compute it or use some random numbers in there, so it's more versatile than that. But if you have some fixed data and want to inline it, then this data table format is very convenient. Okay, so now let me run this maybe. Initially it's passing, then let's make it fail. And now the question is, of course, which of the 3 failed, right? We have 3 iterations, so how can we find out which failed? Initially, we just get this full expression. In this case, I could probably figure it out from the values which one failed, but that's not very convenient. So is there a better way? Because right now, you see, it's just reported as a single method. Even though it runs 3 times, it's just reported as a single method. So we can improve on that by using the unroll annotation. And with that, if I run it again, now each iteration will be reported as a separate method. So you see they are numbered from 0 to 2, so you see the second iteration failed. That's already a little bit better. But actually we can do even better, and I think I have an example for that. Actually, in the name of your test method, you can turn that into a pattern. With the hash sign here, I can refer to those variables, to these data variables. And so for the method names that will be generated, they will just insert the values here. So you have the values, the inputs and the outputs directly in the name of your test method. So if we run now that guy, okay, let's make it fail. Oh, this one, this is a trick, because this one I can't make it fail because it uses the old. and it says the new balance is the old balance minus that one, so I can't make that guy fail. Which makes it kind of an odd example. And I remember I once tried during the presentation to make it fail, and I couldn't do it. But let's do it like this. And I think this one was already failing. So now you now see that the one that withdraws 1 from an account with balance 4, this is the one that failed. So you get a fairly descriptive report, and also on your CI server you would get the same kind of output, and you can detect very quickly what went wrong. So for those kind of tests where it makes sense to vary the inputs and the expected outputs and reuse the same logic, that data-driven tests are a very nice way to do that. I have one more example just to show you that you're not limited to this data syntax. So here I'm using another syntax, and I'm not going into the details of that, but what I'm doing here is I'm now fetching the same values from a SQL database. I'm using an in-memory database here for this example, H2 in-memory database. I set it up here. Usually it would already be set up if it would be an external database, but just for the matter for this example, I create this table and insert some values, again for balance, withdrawn, and remaining. And then in the where block, I use the Groovy SQL class to fetch those values from the database. And for each result returned, the method will run once. So if we run that class, it will do exactly the same as the one before. It also uses unroll, so you can see. This just shows that you can get. Is that a question?
Yeah.
Yeah.
So is there any use case where you would want to use these tables or iterative tested execution, and you would want to see which iteration failed? You
mean why the unroll is even needed or something like that?
Yeah.
The primary reason is tool integration, since if you use the unroll, JUnit expects that all the method names are known before without executing the test class, and that's like some IDEs make this assumption. And so as soon as you use the unroll and the hash and so on, I can no longer tell JUnit or the tool that's driving JUnit what the test names will be. And then in some IDEs you will get some funky, this test was never ran or something like that. So you will get a little bit of a strange output sometimes. And that was a few years back, and that's why it never was the default. But by now it already got quite better. So you see here, for example, in IntelliJ, everything is okay with the output. But occasionally, I think in Eclipse you would still get, you would get a method with that name, with the pattern in it, and it would just say this one was never run. This kind of thing. So that's the main reason. The other reason is that I always had in mind, I don't only want to have this fixed data, but I want to do like property-based testing where I fire at that thing with generated values. And then you might want to run the same test method 10,000 times. And then you might no longer want to have that reported as 10,000 separate methods. So it's a historic thing how it evolved. You can put it on the whole class at least, then it holds for all methods on that class. But currently you have to put it at least once on the whole class, the unroll. Okay, I think that was already everything I wanted to show with data-driven testing. So an extension of state-based testing where you keep executing the same test logic but vary the data. So we had the new block, the where block, we saw the data tables, we saw the external data source, and the unroll to get a better reporting. Okay, how much time do I have left? 10 minutes. Okay. So the third part then is interaction-based testing, and that sounds pretty fancy, but actually most of you have done it already because it's just a fancy term for stopping and mocking. So in other words, Spock comes with its own mocking framework. You can use a mocking framework like Mockito or EasyMock or JMock that you know from the Java space, but you can also use the built-in one. And again, it works for testing Ruby code, but also all the features of the mocking frameworks work for testing Java code. So for those of you who haven't heard about interaction-based testing or stopping or mocking, you are no longer testing the state of an object, but you are testing how objects communicate. So you have one object that you are testing that communicates means calls methods on some other objects, and you now want to verify that communication. Like that this method is called with a parameter in this range twice or something like that. So you now no longer focus on the state of your object under test, but how it communicates with collaborators. And you wouldn't necessarily need a mocking framework for that, but what a mocking framework gives you, it gives you an easy way to implement those collaborators. So of course you don't change the object under test, what you want to test, you test the real thing, but you want to have a quick and easy way to create collaborators that behave just in the way that your test needs them to behave. And you could implement them by hand. You know, if they are declared as interfaces, you could implement test implementations of those collaborators and make them behave just the way you need it. But with the mocking framework, you can do that in a much more concise way, and it will automatically implement those collaborators and verify the interactions that you expect between the object under test and its collaborators. So I'd like to quickly show you how that looks like in Spock, and I have. It's strange. So let's see. Again, we need something to test. This time I wrote the class under test in Groovy, just to show that I can. So this is the class we are going to test. It's just a publish-subscribe pattern where you have one class that notifies others. So we have this publisher class. This has a list of subscribers. Initially it's empty, that's the Groovy syntax for an empty list. And it has one method, publish, so you can publish a method and it simply loops through all the subscribers and calls the receive method. And that subscriber interface, actually, that's up there. So that's the collaborator, the subscriber, which can simply receive a message. Publisher has a list of them, loops through them, and calls the receive method. And one important detail is if a subscriber throws an exception, we swallow that. So in the real world, we would probably log it. But the important thing is that if the subscriber misbehaves, we don't want to give up. We still want to notify the remaining subscribers. Because we want to isolate, basically, the subscriber's problem and still keep notifying the other ones. So the question is now, how could we test the publisher class? With state-based testing, well, we could add some subscribers to the list and then check that they are still there, but that's not very interesting, right? What we really want to know is when we publish a message, will all subscribers be called with the same message? And maybe if one of them messes up and throws an exception, will the other one still be called? That's the kind of thing that we want to know. And of course we could implement this interface by hand a couple of times, just as our tests need it, but with a mocking framework that's a lot easier to do. So let's have a look at how we could do that. That's here. So first of all, we have our spec class, extend specification, and first we set up the object under test and its collaborators. Here I've done it as fields. I could have also have done it right in the method, but just to show that I can, I declared some fields. So I said I instantiate the real publisher, and then I need two subscribers, two implementation of that subscriber interface. And instead of implementing them by hand, I just use the mock method here, that guy mock method. It's actually a method that comes from the specification class, and that will dynamically create an implementation of that interface. It will also work for Java code. So we now have an implementation, two implementations of subscriber that initially are more or less empty. If you call them, they wouldn't do a whole lot. And in the setup method, that corresponds to JUnit's before method. We register the subscribers with the publisher. Here I'm using Groovy syntax. That's another way to add something to a list, the left shift, but I could also have used the Java add method. So I could set pub.subscribers.add sub1 and pub.subscribers.add sub2. Okay, that was the setup part, and now we want to exercise the publisher and check whether it really calls both subscribers. So we do that with the when then. In the when phase we exercise the code. So we say when the publisher publishes some string, some message, then, and now we want to somehow say we expect both receive methods on both subscribers to be called exactly once with an argument that's equal to message. And Spock provides, again, a special language for that. And that's the whole language. That's how you specify the assertion, so to say. You say, I expect the receive method on subscriber 1 to be called exactly once. That's the 1 times. And we expect that the this message will be passed. And the same thing for the subscriber 2. We expect it to be called exactly once, the receive method with this argument. That's all you have to say. And now Spock will make sure that these method calls really happen, and if they don't happen, it will complain. Okay, so we can run this guy. It's okay, and then let's say we expect this method to be called 2 times. Actually, it's only called once. Then this is the kind of output you get. So it says too few invocations for this interaction, as we call it. Actually, there was only one invocation. And it also tells you there were no other invocations. So that's a simple way how you can test the interaction between your object under test and some collaborators. Object under test was the publisher and collaborators were the subscribers. Of course, we can do a lot of fancy other stuff. I just give one more example, the one with the misbehaving ones. So now we want to check if the first subscriber throws an exception, will the second one still be called? And it's very similar. So this part is all the same, setup is the same, this part is the same. We again call the publish message, and now we want to express that we expect the first subscriber to be called, and now we want to give it some behavior. That's the other thing you can do with the mocking framework. First you can say which calls you expect, and then you can also give these collaborators some behavior. That's the stuffing part. And in Spock you do this with the right shift, and on the right hand side you can then add some behavior. And one way to do this is with a closure or a code block. You can give it an arbitrary, some arbitrary code you can put in there. And so whenever this method will be called, the receive method on subscriber 1 with this argument, it will behave as follows. So in this case, it will simply throw an exception. So we verify that the subscriber is called exactly once, make it throw an exception, and then verify that the subscriber 2 still receives the message. That's the way. It's just a language to express those interactions. And then Spock makes sure that they really happen.
It's a bit strange, though, that you define the behavior of the first receive method in the then clause, right? It's kind of...
Yeah, the thing is, in the when block you only put the code that you exercise, the code under test, the behavior, so you exercise the code under test, but the behavior of the collaborators you don't put into the when block. So somehow, one other thing you could do is you could do it as it's more traditionally done. For example, in Mockito you could do it in a setup block. So you could declare that behavior up there if you prefer that style. Or you could also put it in the then block. So actually there are 2 styles that are supported. Yeah, the thing is with all the mocking frameworks, including Spock, excluding Mockito, the 2 things have to be together. So you could move the whole thing up there, that would be fine, but you can't just leave that part up there. That's a feature that's unique to Mockito. Mockito technically works different than most other mocking frameworks, and Spock works technically more like EasyMock or JMock, and that's why if you want to expect a call and make it behave in a certain way, you have to say that in one sentence, basically. Okay. So we won't have time to go into more things. Of course, there's lots more things you can do about mocking. So you see, you can say lots of things. I expect between 1 and 3 calls. I expect at least 1 call. The argument should be anything. I don't care what it is. It should be any string, so type string, but I don't care about the value. It should be anything that's not null. It should be any argument that contains a character. So there are lots of ways to say which interaction you expect. Because one thing with mocking, you should always be careful. Don't over-specify. So you could, nail it down and say, I expect 27 invocations of that method with exactly that argument, followed by 3 invocations of that and 7 of that. But then what you're testing is really not the specification, but the implementation. You should always think what is really the expected behavior of that class, and what is just an implementation detail. And only the expected behavior should be in your spec, and everything that's irrelevant, that's just a coincidence of the current implementation, you should leave out. For example, if the value is not important, then just say any value with Spock. So that would be an underscore, and don't say which value you expect. Because if you nail everything down, then whenever you make a little refactoring to your code, then it's likely that many tests will break. So it's a pitfall with mocking to overspecify, to say things which are not really relevant. So you should try to avoid that, and that's why Spock is very flexible in what you can expect. So here you would say you expect 1 call on any mock object of a method that starts with this character. So this is a regular expression. That's a bit of an extreme example, but it shows you how flexible it is in terms of your expectations. You can also, as I said, make it react in some way. In the easiest case, you just return a value from a method. So this one would, every time this method is called, it would return the string. The second line, it would, on the first invocation, return OK, the second also OK, and from the third on, return fail. So you can already see it's very easy to give your object some behavior. Now imagine you would always implement them yourselves, those test implementations. That would be a lot more effort than giving them some behavior with this language. You can mock and stuff together, we already saw that. So we expect this call to happen and give it some behavior. And then, yes, just to show that the language is kind of that you can use the underscore pretty much anywhere. So I expect this number of calls, so the upper bound and the lower bound are unspecified. So any number of calls on any mock object of any method with any argument list, and we return the default return type of that method. And if you find that somewhere in some code, probably something went wrong, but that's just to show that you can. Okay, that was it about testing. About interaction-based testing. And I'm told I'm pretty much out of time. Last time I was out of time, I could still show one feature, so now I'm thinking which feature should I show? Okay, so I won't show, there's lots of integration with other stuff. So with Spring, for example, if you happen to use the Spring test context framework, it's integrated with Spock. Grails, if you write Grails apps, it's integrated with Spock. It works really well with the CHAP functional web testing tool. But the one thing I probably would show, if it allows me to, is the new report we're working on. So let me see. So people have asked us for higher level reports, for BDD reports, which they can show to your business manager. Like this is the functionality we implemented, something that's not so technical, but higher level. And this is what we currently have. It's still work in progress, but I would like to show you what we have. So this is one way you could do that. It's an extreme example because it's a small spec and shows all examples at once. But basically you can annotate your spec with more information. So you can give it a narrative, as we call it, some textual description. You can give it a nicer title instead of the class name. What else? Here we have the annotations for all the blocks, which you've already seen. And then there's also an annotation by which you can link it to your issue tracker. So if this is a test for some regression in your issue tracker, then you could use the add issue annotation. And if we now execute that one, this is the kind of report that we get. This is still work in progress, but you see here now you have the narrative here, and you can, if you want, you can remove all the results so that it just reads like a specification without, it just reads like what does your software do, and you remove the test results. You can, this became a link into your issue tracker. I'm not connected to the internet, but that would now go to the issue in your issue tracker. You can expand the thing and then you see everything like the standard out and so on. And plugins can add their own data into this report. So for example, the CHAP functional web testing tool, if you're familiar for that, that's something like Selenium, which you can use to simulate a browser that's hitting your web application. And what this CHAP tool does is that after each test method, it makes a screenshot of the web app, so that if something goes wrong with the test, you have the screenshot handy. And what you can do there is CHAP can add its screenshot to the report, that you have it right in the report. And here, without internet, this won't work very well, I'm afraid. But here it would then give you just the screenshot or whatever information some tool based on Spock would provide right in that report. So that's what we are currently working on. It's a surprisingly often asked thing. You can also filter, just show me the past tests or the failed ones or the skipped ones and so on. Now my only hope is that actually someone is going to use that feature. But it's a feature that has been asked for a long time, and so that's why we are finally tackling it. Okay, with that, I'm afraid I'm out of time. If you still have any questions, maybe we have time for one question. Anyone? No? Otherwise, I will probably be here for a few more minutes. Thanks a lot for your attention. I hope you liked what you saw, and you will give either Gradle or Spock or both of them a try. Thanks a lot.